Okay, we will solve the following exercise. The exercise is the number 2.36. In problem 2.35, determine the components of a unit vector, ECA, that points from point C toward point A. Strategy, and it is a hint, determine the components of RCA and then divide the vector RCA by its magnitude. Alright, so I just wrote down here these two dimensions because this is the information that we need from problem 235, and the rest is not necessary. Now, basically, this hint is telling us what to do. Determine the components and then divide by its magnitude. So, what we have right here is basically this triangle in which we have 3, 4, and 6 meters for each cathedrus. Now, they are telling me that from point C to point A we have our vector, right? Now, all we have to do is to take into account point C as our point 0 and determine the magnitude of the components from the vector CA. That means determine this magnitude and this magnitude as well. For example, I'm going to call this magnitude Y and this magnitude X. Now, what do we need for us to solve this exercise? First, we need this angle that we are going to call, for example, alpha, for us to determine this other, for example, beta. Now, beta is going to be equal to 180 minus alpha. That is basically everything. Now that we have that angle, we as well have the hypotenuse of this triangle. We also know that this is a 90 degrees angle. Then that would means that, for example, using the cosine of beta, which is equal to the hypotenuse, to the adjacent cathedrus divided by the hypotenuse, we will be able to determine X. And then we're going to do the same thing for Y, but using the sine, because the sine of the angle is the opposite cathedrus divided by the hypotenuse. Alright, once we have X and Y, we will be able to determine the vector RCA by its components. So that would mean X in the I direction plus Y in the J direction. Now, because we have right here our point 0, that would represent that towards this direction we have positive numbers, and towards this direction we have positive numbers as well. What does it mean? That the Y value, it is not positive, it is negative. Alright, that is what we have right here. Because of the same reason, remember, point 0 towards this direction we have positive numbers. That would mean that X is positive, and toward this direction we have positive numbers. That would represent that Y is negative because it is pointing towards the other direction. That is basically everything. And we have as well the magnitude of the vector RCA, which is equal to the hypotenuse 4 meters. Now the unit vector, and I don't like this nomenclature, I like this one. The unit vector is going to be equal to RCA divided by the magnitude of RCA. And that is pretty much it, guys. Now, how do we determine the alpha angle? We already have all the catheteros of the triangle. So, and this is a rule, guys. Remember, when you have all the catheteros of the triangle and you need to determine a specific angle, please use the cosine law. It is not that difficult. All you have to do is to memorize a simple equation. I know that some teachers don't like to memorize things, but I think it's the easier way. So all you have to do is to say that 6 squared is going to be equal to 3 squared plus 4 squared minus 2 times 3 times 4 multiplied by the cosine of alpha. Alright? Now, why 6 squared? Because it's the opposite catheteros of the angle that I need. That is pretty much everything. So that catheteros square is equal to the other two added, each one squared as well, minus 2 times, once again, 3 times 4, the other two catheteros, multiplied by the cosine of the opposite angle, which is this one. And that's everything, guys. Now, with this equation, we will be able to determine the angle alpha. Now, in this case, 6 squared minus 3 squared minus 4 squared divided by minus 2 times 3 times 4 is going to be equal to the cosine of alpha. Now, the cosine to the minus 1 power of this is equal to the angle. And that's everything. Now the angle is equal to, please be aware that you're using always degrees right here. So cosine to the minus 1 power of 6 squared minus 3 squared minus 4 squared divided by minus 2 times 3 times 4. Alright, now alpha is equal to 117.2796 degrees. Now that we have that, we're going to apply this equation. Now, let me divide this by a step. So first step, second step. So now beta is equal to 180 minus alpha. So 180 minus the answer is equal to, beta is equal to 62.7203 degrees. Now, third step, the cosine of alpha is equal to the x value divided by the hypotenuse, which is 4. That would mean that, and I want to do it all in blue color, blue, right? That would mean that x is equal to the cosine of alpha multiplied by 4. And I'm going to save this answer, so shift storage in the A space of the calculator. Now for when I look for A, when I look for A, this is going to show the result that I just saved. Now the cosine of A multiplied by 4 is equal to 1.833333, etc. Now, therefore, the sine of alpha is going to be equal to y divided by 4. That means that y is equal to the cosine, to the sine of alpha multiplied by 4. (3.5551). I always use 4 significant digits after the comma. Now we have everything that we need, because the vector RCA is equal to 1.83 periodic, the I direction, minus 3.5551 the j direction, and this is in meters. Now we have as well the magnitude of the vector RCA, which is equal to 4, and basically the unit vector RCA is equal to this divided by 4, 0.45 833333 direction, minus 0.8887 the j direction. Now remember, one of the principal characteristics of a unit vector, and that is the reason why it's called a unit vector, is that magnitude has to be equal to 1. Now how do we determine the magnitude? This is equal to the square root of 0.4583 squared plus minus 0.8887 squared, which is the same thing as having the same number but positive. 0.4583 squared. This is not going to be exactly equal to 1, because I am eliminating a lot of decimal numbers after, for example, this tree has a lot of threes right here. So please be aware of that, but we have to be close enough to the 1. For example, 1.000001 or 0.999999. 8887 square. Okay, right here we have it. This is equal to 1, guys. So that would mean that this is the answer. And this is how, guys, you can solve this exercise. All you have to take into account is differentiate some different concepts, basically these ones, and have in mind always the cosine law. As well, you have to manage the sine law, but that law was not necessary in this case. Please check the other videos for you to analyze the sine law. Okay, guys, this is how you can solve these exercises.